Now let us calculate the acceleration of the Moon as it is orbiting Earth. The Moon has almost a circular orbit with a radius given by 384,000 kilometers or 3.8 times 10 to power 8 meters. So this is the radius of the orbit of the Moon. And it completes one full rotation. That is, the period of the orbit of the Earth is 27.3 days. What will be its acceleration? Well, to calculate the acceleration, we will need the speed and the radius of the orbit. The radius we already know, but we need to determine the speed. And the speed we can determine by, since it's doing uniform circular motion, it completes one full rotation in a period t. So in this period, in this time, it covers a total distance of 2 pi r divided by t within a time t. So this is the speed squared, or this is 4 pi squared r over t squared. Now, of course, we still need to express t in terms of seconds. The period of the rotation of the Moon is 27.3 days. 1 day is 24 hours. And 1 hour is 3,600 seconds. And this will tell us that the period of the Moon around the Earth is 2.36 times 10 to power 6 seconds. So we know the radius of the orbit, we know the period of the orbit in terms of meters and seconds, so now we can calculate the acceleration. So this will be equal to 4 pi squared. The radius of the orbit is 3.84 times 10 to power 8 meters, divided by t squared is 2.36 times 10 to power 6 seconds squared, which tells us that the acceleration of the Moon around the Earth is 2.72 times 10 to power minus 3 meters per second squared, which can also be written as 2.74 times 10 to power minus 4 g. So compared to the acceleration of the objects close to the surface of the Earth, the acceleration of the Moon is much smaller. Note that this is not the acceleration of an object that is released from the surface of the Moon. This is the acceleration of an object that is released at a distance of 384,000 kilometers from the center of the Earth, and in that case, it will accelerate by this acceleration.